Spring AI 1.0 shipped in May 2025 as the first stable release of the Java framework designed to simplify the development of LLM-powered applications. By wrapping OpenAI, Alma, and other model providers behind a consistent API, it made it easy for Java developers to add AI features to existing Spring Boot services. Adoption was fast. By early 2026, Spring AI becomes standard dependency across internal enterprise tools, customer-facing chatbots, and AI-assisted search backends. CVE-2026-22738, published on March 26, 2026, System 1 of Spring AI stores components. Simple vector store. It is CVSS 9.8 critical, unauthenticated, and requiring no user interaction. An attacker can reach an exposed API endpoint and achieve full remote code execution on the server, with no credentials and no preparation beyond sending a crafted HTTP request. How RAG pipeline works. To understand where this vulnerability sits, we need a rough picture of how Spring AI is typically used. In a retrieval-augmented generation RAG pipeline, documents are converted into numerical vectors called embeddings and stored in a vector store. When a user asks a question, the application searches the vector store for the most relevant documents, then passes those documents alongside the question to the language model to produce a grounded answer. Simple vector store is Spring AI's built-in memory vector store. It uses a concurrent hash map under the hood and is documented as a component for development and testing. It turns up in production when a prototype never gets migrated to a proper backend, which is more common than the documentation intends. Spring Expression Language. Spring Expression Language (SPL) is a general-purpose expression engine used throughout the Spring framework. It powers conditional bean loading in Spring Boot, access control expressions in Spring Security, and query annotations in Spring Data JPA. SPL supports property access, meta and type operations. When evaluated against trusted internal data, it is safe. When user input reaches the evaluator without indexation, it becomes a code execution primitive. We will work the full attack chain against deployed Spring Boot RAG application running vulnerable Spring AI 1.0.4, tracing vulnerable code path, crafting SPL payloads, catching reverse shell, then switching perspective to detect and patch the vulnerability. Along the way, we will cover why the default evaluation context is dangerous, how standard evaluation context differs from simple evaluation context at the code level, and what log and process signals to look for when this is being exploited. Prerequisites. Familiarity with OS command injection and server-side template injection helps most here. SSDI in particular shares the same root cause. Evaluating user input as code. The OWASP Top 10 2025 is a useful background on injection as a category. Spring 4 shell applies to Spring Boot applications, but it is not required.
New day, new rule. Spring AI CVE 2026-22738. And just hit this complete button. So, simple vector store support metadata filtering, which lets the caller narrow the candidate documents before similarity ranking. A search request is passed with a filter expression describing which documents to include. For example, country equals US. To restrict results to document tags with data value internally. This expression is handled to simple vector. The class responsible for turning that filter into JVM level predicate. The evaluator bits SPEL expression string by concatenating the filter key into a template. We have in here metadata, filter key, filter value, and evaluation context. Evaluate SPEL. The filter key is country. Expression becomes metadata, country equals US. This is the extended operation. The problem is not the template structure. It is the evaluation context used to execute the expression. Standard evaluation context vs simple evaluation cost. So we have here comparison of these two things. We have the standard value context, full JVM, reflection, method invocation, type loading via T, pins, etc. Intel framework operations with trusted into only. Simple evaluation context, read-only property, and array access, no type loading. Any expression touches user control input. So now we have the Java lang runtime, get runtime, exec ID. So we have the reflection get runtime, current JVM runtime instance. type expression. We have invoked method in the JVM when the string contains user supplied input. The user controls the program execution. So we have T is SPLS type operator, fully qualified class name, and returns the class itself, giving access to static methods and field without the explicit Java reflection boilerplate. For Java lang runtime, the static method getRuntime returns current runtime instance and exec on that instance launches OS process BI. Beyond runtime, there are other useful targets. So we have slip get property version, and we have get runtime and full CE. The attack surface any Spring AI application that accepts user control HTTP parameter places into search request filter expression key without validation, calls simple vector store similarity search with that request is vulnerable. The pattern is common in RAC backends, where the user filters documents by metadata such as language, category, or data range. The application developer associates the user filter selection with search request without treating it as untrusted data. So basically it's trusted without checking. CVE 2026-22738 is not a first time Spring component has shipped. Standard evaluation context as evaluator for user supplied input. We had it in 2022, 9, 30, 63, hit Spring Cloud Function. HTTP header named Spring Cloud Function, routing expressions allowed, calls to route request to function named, and that expression was evaluated with the standard evaluation context. The result was same, unauthenticated RCE CVE 9.8. The fix Spring Cloud Function was identical to fix the Spring 4 years later. Replace standard evaluation context with simple evaluation context. The parameter recalled, because standard evaluation context is a framework default, and developers who reach for SPEL for new features do not always consider that happens when the input is untrusted. So let me bind does not equal. So is a different class entirely in data binding gadget that does not involve SPEL. It was given separate from the pattern. MITRE attack maps this attack T 1190 exploit public facing application for initial access in T 1059 00 for Unix shell for execution via result reverse shell. The word evaluation code does the vulnerable version use to evaluate filter expression that we have. I guess this one. About the standard evaluation context. What SPEL operator loads the Java class by its fully qualified name? I guess did something. This is it. This one. All Spring component had the same SPL injection flow in 2022. We have cloud function. I guess. So now we need download the file task files. Both scripts are available to download from this task. Before we touch the machine, it's worth to understand exactly what each tool does. Running script against the live target without knowing its internals is how the things go wrong. And in this case, the internals also explain the vulnerability clearly. Exploit pi runs 4 stages. Attack chain against search endpoint. Each stage builds on the last, moving from the passive check to the confirm OS level code execution. Third stage, state baseline, then the normal get request, search, filter key, country, filter value, US, query hello there. This confirms the endpoint is alive, and the application returns seeded document with country US metadata field. If stages fails, there is no point continuing. The second stage, step spare probe, injects the read-only SPEL expression into the filter key parameter that we have in the metadata. And though this uses lang system to read the JVM's version property, no OS process is spawned here. The Java version string appears in the response body, or we receive the evaluation error instead the normal response. Both outcomes confirm that our input search the SPEL evaluator. This is injection point. The third stage, step SCE touch, escalates to OS execution. So now we have the runtime. Command is harmless touch. Temp, point, SVE, and the number. We do not need the commands. Output to come back in the HTTP response. We look for something else instead. When exec returns SPEL, tries to concatenate the result, process EMPL object with the round expression to the add operator. It cannot, so it throws operator add is not supported between objects of the type null and Java lang process MPL. So that error appears in a HTTP response body and it fires after process was already spawned. In the script, this is the success check. Very nice. So we have EL 1030E. Think LE 1030E is a response body is how exploit pi confirms runtime exec was invoked. Stage 4 step RCE ID, write the output of ID uname -a k etc hostname enter temp RCE proof text. This gives 3 pieces of identifying information by the target without needing to interact the shell. The core payload build is 3 and 4 is. This is it. New string bin bash c command. So the outer double quote is honored decoration. Then filter key starts with a single quote. The filter text passes is as a quoted string literally and strips the surrounding quotes before constructing the SPEL expression, which mangles the payload, wrapping in double quotes as the parser to strip those instead, leaving the entire single quotes content to be embedded verbatim into the SPEL template. The evaluator then seems a valid expression with our command in it. Python 3 exploit target, and we have the address. This is it here. This is the address 35 8082, and then wait. Now listen, handle the reverse shell. It is not 2 modes. Listener only mode. It binds HTTP circuit and waits for incoming connection. When the shell connects, it entires the interactive loop forward your STDN in the socket and prints everything the shell sends back. In the exploit mode, start with the listener first and fires SPEL reverse payload. In background thread, start the listener before firing the payload meters. The target machine connects back almost immediately, and if the socket is not ready, it misses the connection. The reverse shell payload has characters conflict with problem. The raw bash command will not work, so we have the pound sign and the backslash, I guess, character, and the break the filter pass if passed in the plain text inside the single ports. The script invoices by base 64 encoding the entire shell command first. Very nice of you. The encoded payload decodes and executes cleanly inside the SPEL expression without any single quote conflicts with the path, reaching the path. When the shell connects, listener part automatically sends who am I and ID to the hostname IP command to identify execution contest. We see the answer without typing anything. So we have this one, our VPN IP L host. I guess this will be my host. So, what string in the HTTP response confirms that exec fired? Let me go in here. This one will be fine. This will be the success, baby. What file does this stage 3 create on the target machine? What? Target. Stage 3. I get this one. Taking you too long. Take this one. What flag makes listener fire payload and listen to the in the one command? What flag makes listener fire the payload? Flag, I guess this one. I don't know. Let me check. Target online exploit. I guess the exploit. That's it. So now machine is on. Let me real quick add the hour in here. Do this TryHackMe zone is just taking tech machine to some place. You need to search how to get there. Why is that? Off topic. If you guys from TryHackMe listening me, just bring the spawn attack machine back. With the button. Why do I need to search this? Back to the room. The payload machine runs Springboard application backed by Spring AI version 1.0.4. It acts as a RAG chatbot API. Documents have been feeded in a simple vector store with metadata including country field and a search endpoint, except filter key and value to restrict which documents are considered during similarity search. Start the machine, wait until the web service is ready on port. This is the port. To stage 1, baseline check. Let me do this baseline check first. Don't sweat. It's only big check. Simple check. Let me see. So we have country USA. So it is indeed working. Hello world. This is the city test. Document 4 CVE number. So now we exploit. Where did I downloaded this exploit for? This is it. So the uploading exploit was horrible. I cannot find public IP. So guys, from the TryHackMe, fix it. It's not working. Thanks. Back to the business. So we have listener in exploit bunch code. I have it here. So I need to do this one. Wait a minute. Hold it. Wait a minute. Something is right. Let me clean this one. And paste it in. This is exploit likely succeeded. Received but Docker. Verify was skipped. Manual check. Docker. Cut. Let me see. I guess we will see error. Okay. Let me just tag this one. Let me see. Get this one with the 10 3 8 6 3 5. No such container. Okay. Never mind. Let me check this one. If the target is right. Wait a minute. Don't rush. 10 3 6 1 1 1. Airport. Nothing. Cannot assign requested address. What's your problem? Which one cannot you assign? Cut the flock. 444. Let me see here. State. Tuna. Let me see. Grip. 444. Nothing. Dude. 1 10. Oh, thank you very much. We have it. Cut. Vote. Flag, I guess. TXT. Do we have it? I don't know. Cat. Wood. Flag. TXT. ID. Row. Okay. CD. Row. DVD. Row. LS. Row. Row. TXT. We have it. So, what port Valor is running on? 80 something. 8082. Use application running is just use ID root. Move the flag. Let me check this flag. That's it. So now it's detecting a patching. Let me take some breaks. Switching perspective. If the application were running in a production, an attacker exploited CVE, what would we see and what would we do about it? Application log signature. When SPEL payload triggers, the EL1030E error the application logs. A Java exception. The stack trace includes two strings that are reliable indicators of exploitation attempt. Those are operation aid and not supported between objects, and the error itself. SPEL evaluation exception. In the stack trace of the vector store component is not normal application error. The log aggregation pipeline, whether Splunk, Elasticsearch, CloudWatch, should alert them both. SPL. Evaluation exception. Simple vector store filter expression evaluator appears together in the same stack trace. We have it. This one and this one. So that combination is not a pass the application reaches through the normal use. To know this signature is only a piece when add operation fails after exec returns the upload that avoids triggering that error. Pass produces no log entry, which is why process level monitoring covered below is a more reliable backstop. HTTP request indicators. So the SPL payload traverses a query parameter in the GET request, and WAF or API gateway inspecting incoming request should alert when the filter key parameter contains tjava. The SPL type operator get runtime exec narrowed to avoid false positive to field names like executor ID, process builder. We have this one, regexp, pattern covering the type operator. There is a critical caveat with the regexp, the whitespace tolerant. The regexp, javalang runtime, and tjava is the identical to evaluate. The WAF rule does not simply substring match, can be bypassed by inserting spaces. Effectively must normalize to strip whitespace before matching, or use a pattern that allows optional whitespace between T and race class name. JVM child process monitoring. A Spring Boot application serves HTTP request has no legitimate reason to spawn bash sh curl child process. OS level process monitoring catches the reverse shell even when the HTTP payload is obfuscated beyond WAF detection. A Falco rule that covered this rule Java process spawns shell. So we have bash sh curl wget, and all these is command line parent process being a critical patching. The patching fix, you need to upgrade from what you have to 105 and 114 single line change. Simple vector store filter expression evaluator. Simple vector. Dangerous context is replaced with restricted one. Standard context. For read-only data binding build. This is it. All Java exception class appears in a stack trace during exploitation. We have this one. Yes, no, this one. What Spring AI version fixes for the X branch? I guess this one. There too. But this is for sure. No. Okay. This one. What evaluation code it does patched version use? Evaluation context. Standard evaluation context. Yes. No. Simple evaluation context. Whoa. That's it. Conclusions. The follows direct pass. User input arrives with HTTP query parameter flows into SPEL template without sanitization and reaches standard evaluation context, which tears it as a trusted expression and executes whatever it contains. A single T Java lang runtime get runtime exec. Call data, the attacker has the shell changing single line in the single class, close the vulnerability entirely. The white point, the wider point, that expression language execution is a pattern, not a one-off. SPEL, OGNL, and a Java EL all share same root counts. User input is passed to the expression evaluation configured. For trusted data, template engines like FreeMaker and Ninja 2 read the same output via different mechanism. SSDI, where the template itself has attacker control rather than the evaluated context. CVE 2022-22738 use the same technique against Spring Cloud Function. 4 years earlier, the Spring component and early point changed, but the vulnerability class persisted because the standard evaluation context remained the default. That's true. So we will continue with this one. Spring for Shield. Server-side template injection or WASP Top 10 2025. The border indexing categories with vulnerability for and for now we just finished this one. Thank you very much everyone that participated in this room. That's it. We have green one. Room completed. So long. To the bye-bye.